Hello everyone, welcome back to the online session on Elements of Mechanical Engineering. I am Professor Abhishek Gowda from the Department of Mechanical Engineering, MIT Mysore. In previous sessions, you have learnt about the Introduction to Mechanical Engineering and steam formation and its applications. So, in continuation to that, in today's class, we are going to learn the energy sources and power plant. Energy sources and power plant. We must know the importance or the need of the energy sources, because energy, when we say energy, means the basic definition or the common definition which will come to our mind is the capacity to work is called energy. But this energy will be in the form of different types, different kinds, and extraction mechanism is also different. So here in this syllabus, we are going to see the different sources of these energies, how we are going to generate energy from different sources, and what are all the mechanisms that we are going to use to generate these resources. So that is what we are going to learn in today's session. Before going to see the different working principles of these energy sources, let us know the classification of this energy sources. Classification of energy sources. See, we can classify this energy into several types, but based on the factors, we are going to differentiate into different types of the sources. Let us know those factors, on what factor we are going to differentiate or we are going to categorize these sources. A very first one is based on the usability of energy. Based on the usability of energy. So from this factor or based on this factor, we are going to categorize into two types, that is primary resources, secondary resources. Primary resources means these include resources which are embedded in nature prior to undergoing any man-made conversions or transformations, like coal, crude oil, or the solar energy, wind, or geothermal. So these are all the main sources, or we can say the first sources of the energies. So these will be categorized as a primary resources. Next, we have the secondary resources. Secondary resources means the resources which are directly supplied to the consumers or the customers. So that will be categorized as a secondary resources. For example, electricity. Electricity is the energy resources that we are going to supply to the consumer directly, but the generation of electricity is different, means the mechanism, extraction mechanism or the main sources are different. That is the primary resources, but using that primary resources, we are generating the secondary resources, and that will be the direct energy that we are supplying to the consumers. So that will be categorized under secondary resources. So like this, based on the usability of energy, how we are utilizing it, based on that we have categorized under primary resources and secondary resources. Now we will see the next one, based on the tradition. Based on the tradition, which means to say the resources which we are using traditionally, I mean like from so many decades, we are constantly utilizing some common sources. Okay, for example, like petrol, diesel, coal and all. So that and all like a traditional based sources. We are using it from so many decades. Okay, so for this kind of resources, we are going to categorize as conventional resources, conventional energy resources, which have been traditionally being used from so many decades. Then we have one more type under this, that is the non-conventional resources. Non-conventional resources. Non-conventional energy resources means there is one act called Oil Crisis Act. During 1973 it was established because of some of the problems related to the oil with the Arab countries. So this act has been emerged. So after this act, I mean Oil Crisis Act of 1973, we have been switched over to some of the renewable sources kind of energies like solar energy, wind energy, geothermal energy, etc. So that era has been started from that period. So when we shifted over to such kind of resources, so that will be categorized as a non-conventional energy resources. Non-conventional energy resources. Conventional energy resources means which have been traditionally being used from so many decades. Non-conventional means after the Oil Crisis Act of 1973, whatever the resource have been emerged like solar, wind and all, so that will be call it as a non-conventional energy resources. So this is how we are going to categorize based on the traditional type. Next we'll see based on the long-term availability. Based on the long-term availability, I'll write here. The first type is under this renewable energy resources. The second one is non-renewable energy resources. Based on the long-term availability. As the name itself, it is suggesting long-term availability. For example, renewable energy is the first type. No. So, renewable means what? Which we can generate again and again, and which does not have any kind of the duration. I mean fixed duration. After we don't have the fear that after certain duration of years, it won't be like over, or it won't be get extracted again and again. But in the non-conventional energy, I mean in the non-renewable energy, we can't generate again and again. It has some finite time. After that time, it gets over. So, because of this reason, it has been categorized into renewable and non-renewable. Renewable means which we can generate again and again. For example, solar, wind, water. These are all available in the nature that we can generate and again we can use it and again and again, and it does not have any kind of the finite duration. It is inexhaustible, right? So that is why it is the renewable energy sources. And in non-renewable energy sources like petrol, diesel and all, it has certain period of time, the time duration. After it get over. So that is why it has been categorized under non-renewable energy sources. So based on the long-term availability, we have renewable energy, non-renewable energy resources. The next one, based on the origin. Based on the origin. Based on the origin means here the generating energy from different sources, I mean the main original sources, so that will be categorized under this factor. So that is like solar, wind, water, geothermal. So like this, based on the source, for example, solar, sun energy, that is the main source, right? That is the origin. So from that we are extracting energy and we are converting into some other kind of energy. In the same way, wind, we are utilizing the air which are available in the atmosphere and we are generating some sort of energy. Then water, we are storing the water in the reservoir and utilizing that water we can generate some sort of energy. So this is how, I mean, the main original sources. So from that we are generating it. So that is why it has been classified under the based on the origin. Let us see one more time. First one, based on the usability of energy, primary resources and secondary resources. Then based on the traditional usage, conventional energy sources and non-conventional energy sources. Then based on the long-term availability, renewable energy, non-renewable energy. Based on the origin, I mean the main sources, the solar, wind, water, idle power and all. So that will be categorized in the based on the origin. So this is the main classifications of the energy sources, and these energy will be utilizing in the different sectors. The major 4 end use sectors, that is, first one commercial, second one industrial, third one residential, and fourth one transportation. The major end use sectors of this energy are classified at 4 types: commercial, industrial, residential and transportation. Commercial means, as the name it is saying that, and if we are taking or if you are paying certain amount to that energy, means that will be the commercial end sectors. Next, industrial. Industrial means the amount of electricity which we are going to supply to the industries are different from other, because the kind of work what the industry people are carrying, so that is different. So the supplying amount of electricity is also different. So that is also major end use sectors. Then residential. Yes, we all know that in the residential areas we have certain restriction and certain limitations, so that we have to be used within that limit only. So that is the major end use sectors. It has certain rules and regulations also. So that is why it is also one of the major end use sectors. Then transportation. One of the best example, see, in Indian railways, previously they are using diesel as a fuel to run the train, but nowadays almost 70 to 80% of the trains have been switched over to the electric trains. I mean, they are using the electricity to run the train instead of the diesel. So, and in the automobile sector also, we are all like shifting to the electric based vehicles, like 2-wheeler and even in 4-wheeler also. So this is the era what has been evolved now, like for our future growth of the country, and that is why it has been classified as the major end use sectors, that is the transportation. So these are the 4 end use sectors of the utilization of the energy. First one, commercial, industrial, residential and transportation sectors. Now in the syllabus with respect to this energy sources and power plant, we have to study the working principles of the different sources like hydroelectric power plant, thermal power plant, nuclear power plant, wind power plant, tidal power plant. So we have to learn the basic working principle of all these sources and respective power plants. That will be discussed one by one. First one, hydroelectric power plant. As the name it is suggesting that hydroelectric power plant. Hydro means what? The tidal power, the storing of water in the reservoir. Then we can utilize that water to generate the electricity, because water, so that will be naturally available in the nature, and we have so much of rivers across the country, and if we construct a proper dam, and the backwater of this dam, that will be called as a reservoir, so there we can store the water, and using that stored water we can generate the electricity. So for this concept we call it as a hydroelectric power plant. In this hydroelectric power plant we will be utilizing the two kind of energies. One is potential energy and one more kinetic energy. Potential energy means like we are storing water in the reservoirs, so that will be the kind of potential energy, and when we are releasing the water from reservoir to the powerhouse, so that will be the movement of water going to take in place, and from that we will be generate the electricity. So since that movement has been taken place, so that will be the kind of the kinetic energy. So here we are utilizing the both kind of energies, kinetic energy as well as the potential energy. Now let us see the working principle of this hydel power plant. You can observe the clear sketch of the hydroelectric power plant. Here I have written the numbers from 1 to 8, so that will be named here. The very first one, that is number 1, that is the reservoir. So it is the reservoir where we are going to store the water. I mean to say the backside portion of the dam. So that will be the reservoir. Then here this is the second one, dam. So the main thing, or the a big wall that has been constructed as a resisting part to store the water. Then we have the pressure wall here, the number 3 pressure wall. In this you can observe here we have one more part, that is the gates. I mean we call it as a sluice gates. So these gates are utilized to release the water from the dam to the required area. So that gate we call it as a sluice gates. And here we have one pressure house here to regulate the pressure of the or the flow of the water, because here we are storing the huge quantity of water, and if you are releasing it, absolutely the flow rate and the pressure will be very high. So just to regulate it, we are utilizing the pressure valve. Then next we have fourth one, this channel, that is the penstock. This is a cylindrical kind of concrete object, and through this we are supplying the water from higher place to the lower place. So for this cylindrical object we call it as a penstock. Through this we are releasing the water, and for this penstock here we have the number 5, that is the supporting blocks. Supporting blocks. Why do we need the supporting blocks? Means since the pressure and the flow rate is high of the water when we are releasing it from the reservoir, so as the channel of this cylindrical object, so it will be like compact within certain limit. So to avoid a kind of vibration or to avoid the exploitation of this water, we are utilizing this supporting blocks just to hold this penstock tightly, and the water can supply smoothly from the required area. So that is the supporting blocks. Then next we have the 6th one, powerhouse. This is the main place where we are generating the electricity from this water. Let us see the components what we have in this powerhouse. The very first one is the turbine, water turbine. So this is the main mechanical device which we are going to convert this flowing water into the electricity, which means to say this is the turbine, and for this turbine a shaft has been connected, and that shaft has been another end of the shaft has been connected to the generator. Okay, so as the water coming from the penstock, and it will hits or splash on the blades of the turbine, water turbine, and due to that movement turbine is going to rotate, and because of that, which in turn it is connected with the shaft, even shaft is also start to rotate. So that is also connected with the generator, and the generator is going to generate the electricity. This is how we are generating electricity from the water. So powerhouse has the main major mechanical components, that is the turbine, shaft, generator. So using this we can generate the electricity, and after generating the electricity, so it has been supplied to the transmission tower wherever the electric grid has been established. So there we are going to store, or we are going to save this energy, and afterwards we can like supply to the required area. And one more thing, important thing, that is the number 8, that is the tail race. See, after it is splashing on the turbine blade and it has been settled at the bottom place. So this water we call it as a tail race. Either we can use this water for the agricultural purpose, or else we can again pump back to the reservoir also. So again we can repeat the process. Either we can supply to the agricultural usage, or else we can like transfer back to the reservoir also using the pumps. So this is the 8th one, that is the tail race. This is the overall working of the hydroelectric power plant. See, I'll just repeat it once again. So here in the reservoir we are storing the water, and whenever it is required we are releasing through the penstock. Before releasing to the penstock, we have the gates, opening gates, that is called sluice gates, and we have the pressure valve also to regulate the flow of water. And water is going to flow through the penstock, and it is like splashing or hitting on the turbine blades. And because of this, turbine is rotating, and the shaft is which in turn connected with the turbine, it is going to rotate and it will generate the electricity using the generator, and that electricity has been storing in the transmission tower. Thereafter we can use it whenever it is required. So this is how hydroelectric power plant is work. So we have a different hydroelectric power plant we have in our Karnataka state. For example, Sharavati hydroelectric plant, Shivanasamudra hydroelectric plant. So these are the examples for the hydroelectric plant. You can visit those plants and you can see the actual setup and actual components of this power plant also, so that you will get an idea how it has been like working and all. So that is what the importance of the hydroelectric power plant. Next, we'll see the thermal power plant. You can see the complete sketch or a complete setup of the thermal power plant on the board. As the name itself, it is saying that thermal power plant. It is nothing but a kind of heat that we are creating it, and we can use that heat to generate the electricity. Heat, in the sense, it will be in the form of enormous amount of heat that we need to create, and utilizing that heat we can generate the electricity. So using this heat to generation of this electricity, so this will be taken place in this power plant. So that is why we call it as a thermal power plant. And I want to tell you one more thing. This is the main kind of power plant what we are generating the electricity and utilizing also. We are majorly dependent on the thermal power plant. The major thermal power plant which has been located in our Karnataka state is the Raichur thermal power plant. So that is the major thermal power plant, what we are generating the electricity using the heat. The maximum capacity of the electricity we are generating from the thermal power plant, and we are utilizing in our day-to-day life. So here we are going to see the actual working of this thermal power plant. Okay, so as I said, we need to create the heat, means we need to generate it, right? So to generate the heat also, we need some sort of sources, right? So here we are utilizing the coal as the source to generate the heat, because when we burn the coal, it will generate the heat. So using that heat, we can utilize for the generation of electricity. So this coal will be basically in the form of like a large shaped stone. Okay, so it will be in the form of stone. But we can't supply this raw coal in the hopper. So here you can see the hopper. So through this hopper only we need to supply the coal, but we can't like directly dump this coal into that hopper. So we are going to cut or grind this coal into small pieces. So that will be taken place in the pulverizer. So pulverizer is the mechanical device which we are going to, cut it or grind the coal into small pieces. So then we can burn it and we can supply the heat. So after burning this coal, we will generate the heat and will supply this heat into the boiler. Boiler is a cylindrical vessel where we have the actual inside setup like tubes or other kind of elements. We are going to set up inside that closed vessel, so that we call it as a boiler. So inside the boiler you can see the piping setups. So for this boiler we are supplying this heat. Heat means when we are going to burn this coal, no, so it will generate the heat. So this heat will be supplying to the boiler. In this boiler we have a piping arrangements. Here we are supplying the cold water through this pipe. Here we have a mechanical pump, and here we have the water storage tank. Using this pump we are supplying the cold water through this pipe. Since it has been housed inside the boiler and we are supplying the heat, the water in that pipe, so it will get heat up. As continuously supplying it, the liquid is converting into the steam form. So here the water will be in the liquid form, then it will be get converted into steam form. So then after heating this, and when we get this steam, the steam will be supplied to the turbine. So due to this high steam, the turbine is going to rotate. Again the same procedure. Turbine is going to rotate, which in turn connected with the generator through the shaft, and it will generate the electricity. Understand? See, here we are supplying the cold water and we are providing heat by burning the coal. Then the water is getting converted into the steam. Steam's continuous supply of heat, and the steam is supplying to the turbine. The turbine is start rotating, which in turn connected with the generator, and it is start generating the electricity. After this, the steam is again entering the condenser. The condenser is a mechanical device which is going to condense the one form of liquid state into another. So that will be condensed into the liquid. Okay. So with the help of the cooling tower has been attached to the condenser. Condenser is going to condense the steam into liquid. Then the water, liquid means here the water. So steam is get converted into water. Then the water will be settled in the storage tank. So it will get condensed, and the condensed water is come and get stored in the water tank. Using the pump, whenever it is required, we can again supply to the boiler, and the process is going to repeat it again. Same, here we need to burn the coal, we need to provide some sort of heat, and then it is get heat up and it will get converted into the steam. Using the steam, we can generate the electricity. So this is how thermal power plant is going to be work. Here the main thing is the actual components, that is the turbine, shaft, generator, again a small powerhouse. Here it is very important. If it is working properly means we can generate the electricity continuously without any interruption. Suppose if we get any problem in the powerhouse, like the shaft, turbine blades or anything else, so we may expect some difficulty in generating the electricity. And the main thing, the main source to create heat, that is the coal. So we need to purchase the coal, or we need to import coal from other countries or some other region, and also. So this is the working principle of the thermal power plant. Now we will see the tidal power plant. Tidal power plant, as the name suggesting, that tides. How do we get these tides? The geographical conditions or the geographical relationship between the earth, moon and sun. So because of this reason, we will get the high tides and the low tides. Tides is nothing but the rise and fall of the sea level. So sometimes the water level in the sea will be high, and sometimes the water level in the sea will be low. So this is because of the geographical conditions or the relationship between the earth, moon and the sun. So because of this, we will get the tides, high tides and the low tides. So utilizing this concept also, we can generate the electricity. For example, you can see the diagrams of the low tide as well as the high tide. Okay, so here we have water basin, and there is one dam and the sea. Always we are going to create the water basin near to the sea, and when we have the low tide, okay, so during that time we are going to release the water in the water basin. Already stored water in the water basin will be released to the sea. When we are releasing this stored water in the water basin to the sea through a channel in the dam. So in that we have fixed the water turbine. When water is flowing from water basin to the sea level, sea, so it has to be passes through this turbine. So during that moment, turbine is going to rotate. As we know what the turbine will do, it is going to couple with the generator, which we are going to generate the electricity. And now you may get confused that how we will get the water in that water basin. Okay, you will get the answer now. See, during the high tide means the water level in the sea will be high. During that moment, the water will be flow to the water basin. So at that moment, water will flow to the water basin again through the turbine. Okay, from sea to the water basin, the water is flowing through the turbine. Again, turbine is going to rotate and it will generate electricity. So it is vice versa with respect to the high tide and low tide. During high tide, water flows from sea to the water basin. During low tide, water will flow from water basin to the sea. In between, in both the cases, we have the turbine, and turbine is going to start to rotate. It is connected to the generator through the shaft, and it will generate the electricity. So this is how we can generate the electricity using the tide concept. So here we need to understand what is the meaning of tides and how we are getting these tides, and what happens during the high tides and the low tides. During the high tides, water will be flow from the sea to the water basin, and during low tide, the water will flow from water basin to the sea. In both the cases, we have the turbine, and turbine is going to rotate and it will generate the electricity. So this is the working principle of the tidal power plant.